So here's another example to show you how to factorize a quadratic expression using the guess method. Now in this example I'm going to go through things a little bit quickly because in the first example I went through things slowly, so hopefully you understood the idea. The point of this example is to revise the techniques but also show you an extra tip. So let's get on with the basic idea of how you take guesses at factorizing this quadratic expression. So every single guess should multiply to make the beginnings and the end of the thing you're trying to factorize. So this stuff should multiply to make this stuff and this at least. Don't worry about the minus 6x yet. So how do you check that? Well, the beginnings should multiply to make the beginning there, and the ends should multiply to make the end there. So x times x makes x squared, and minus 5 times minus 1 makes 5. Okay, that's a valid guess. Now there are other possibilities. This is the thing I really wanted to highlight in this example. I could have said something like positive 5 and positive 1. Why didn't I do that? Why did I use minus 5 and minus 1? And there's a good reason for that. Well, I'll quickly reintroduce this double chin before I can explain why I use minus numbers. So the double chin basically works like this. This inner chin, because it looks like a double chin by the way, right? This inner chin multiplies the inner numbers in the brackets, and the outer chin multiplies the outer numbers. So the inner chin says minus 5 times x, which is minus 5x, and the outer chin says x times minus 1, which is minus x, and putting it together gives you minus 6x, right? And that happened to be the right thing. That had to be the right guess, because I wanted minus 6x in the middle. These double chins give you that middle number. It focuses on the stuff you need to multiply to make the middle number. You could have multiplied it all out yourself, but this is like the efficient way of doing things, right? Anyway, why did I choose minus 5 and minus 1 rather than positive 5 and positive 1? Because I can see in the thing I'm trying to factorize, I can see there's a minus, right? So if I use positive 5 and positive 1, there's no way the double chin would give me a negative number, because everything's positive. If I had positive 5 and positive 1, I'd get 5x and another x, which is 6x. So no way would that give me a negative number. So that gave me a clue that I needed to use negative numbers. Now if I use one negative number here and a positive number there, like minus 5 and positive 1, minus 5 times 1 would make minus 5, and I want positive 5. So basically, when I saw there was a negative number here and a positive number there, I needed to use two negative numbers to get me both the positive number here and a negative number there. So that's a tip. If you see a positive number here and a negative number there, you know, well, the negative number tells you there has to be at least one negative number in this factorization, and this positive number tells you that, well, both of the numbers have to be negative, because a minus times a minus makes a plus. And that's it really.